Well, here we are again, and let us continue with our discussion of naming. Last time we talked about naming ions, and we talked about naming polyatomic ions, we talked about naming monatomic ions, and cations and anions and all that. Now we want to get into how do we put these things together and name a binary ionic compound. And in this case, we have a binary ionic compound between bromine and magnesium. What is the formula and the name for this compound? Okay, so let's take some notes. Okay, we were talking about naming, right? And we came over here the other day and said, hey, we can name ions, and we have polyatomic, and we have monatomic, right? And then we can have some cations here that we name in one way, and we have anions here, right? And with anions, hey, we take a stem and we put the word "ide." And then in cations, we have really two types of cations. We have single cations, we might call them elements that form just one cation, and then we have elements which form multiple cations, right? And with the single cation, it's pretty simple. You just say, hey, metal, whatever the metal name is, and the word cation, like magnesium cation. With multiple cations, we have to put the charge in parentheses, right, in Roman numerals. So if I have Fe2 plus, I have to write that out as iron 2. And which guys are these multiple cations? Well, my D block, my F block, and my P block metals, by and large, with the exceptions of what? Silver is always +1, cadmium is always +2, zinc is always +2, and aluminum is always +3, right? And so these guys act as single cation elements, and we just write aluminum, cation, or silver. We don't use the Roman numeral. Good. So now today we want to talk about our compounds. Okay, compounds. And we know we have two types of compounds, right? We have molecular, and we'll wait on that a little bit. Molecular compounds, right, between a nonmetal and a nonmetal in which electrons are shared. And we have ionic. Okay, so how is it that we go about handling an ionic compound? Now remember, in an ionic compound, we have a nonmetal plus a metal. That's what we're looking for, and that's how we're going to decide how to name it. Okay, first of all, let's talk about writing our formula. How do we write the formula? Well, first thing is the metal comes first. So we have a metal first. All right. And that would mean my nonmetal is second. Secondly, we have to look at the charges on our cation and anion, and we want to find a least common multiple for the charges. And you guys know what least common multiple that is. What's the lowest number that both of these things can be multiplied into evenly? So if I have a +3 and a -2, what's the least common multiple? The least common multiple is 6, because 3 will go in there 2 times, 2 will go into there 3 times. Good. So we find the least common multiple based on their charges, and then determine the number of the atoms needed to reach that least common multiple, like we just did here. I said, hey, if I have a +3, I need 2 of these to get up to 6. And if I have a -2, I need 3 of those to get to -6. Okay? And what are we really talking about here? We're really saying how many electrons need to be lost here and how many electrons need to be gained here, right? We're saying with my metal, which each time my cation, excuse me, let me slow down. If I have a cation that is a +3, right, like aluminum 3+, how did it get 3+? Well, it lost 3 electrons. And if I have an oxygen, which is a 2-, how did it get 2-? It gained 2 electrons. Well, we're assuming all those electrons go where? From the aluminum. We're assuming they're going to the oxygen, right? So How many aluminums does it take? Well, I'm going to have two aluminums, and that will provide 6 electrons. Well, now, how many oxygens does it take to use up 6 electrons? Well, I need 2 each. 2 times what number gives me 6? 3. So I need 3 oxygens to have my charges balanced. And I guess that's really what we're after here is, okay, number 3, number of atoms to reach least common multiple, and then 4, right, add number of atoms as a subscript. As subscript, yikes, after element symbol. Good. Okay, and really the overall writing thing here is my charges, the total charge, and what does that mean, total charge? Number of cations times charge must equal, total charge must equal 0. And that means number of cations times charge must equal the number of anions times charge of anion, charge of cation, and charge of anion. Sorry that's a little messy. Good, so let's take our aluminum and our oxygen like I had up here. Aluminum, when I look at my periodic table, it's going to form, whoa, man, what a mess. Aluminum is going to form what? It's right here. This is +1, +2. Aluminum is +3, right? Or 3 plus. Oxygen is what? Needs to pick up 2, 2 minus. So we have a 3 plus and a 2 minus. So here we go. Let's go to our notes. Let's come down here. Aluminum is going to form a 3 plus. Oxygen is going to form a 2 minus. Good. So what's my least common multiple? 3 times 2 is 6. I need to have 6 electrons lost by aluminum, and I need to have 6 electrons gained by oxygen. Okay, so how many aluminums does it take for me to get 6 electrons? Well, 2. So I'm going to write down Al2. Remember, my metal comes first. Oxygen. How many oxygens are needed to use up 6 electrons? Well, if each oxygen uses 2, I will need 3 oxygens to use up 6 electrons. So O3. There we go. So that is my formula for the ionic compound of aluminum and oxygen. Now, how do I name this? Wow, that was just a formula. Let's come down this way and talk about naming. Hey, naming is easy, folks. Yikes! Naming. How do we name this? Naming ionic compounds. Simple. Metal first, plus the anion name. Yay! So my metal is what? Aluminum. Aluminum. And what's my anion name? Well, it is oxygen. So we start off with my stem ox, and we put what? Ide, because it is an anion. And so this would be aluminum oxide. That's all there is to it. Good. All right. Back to our question. Magnesium and bromide. So I have a magnesium. Metal goes first. My bromine is going to go second. What are their charges when they are ions? Where's magnesium? Here's magnesium. It is a 2 plus. Where's bromine? Here's bromine. It is a 1 minus. So this is a 2 plus, and this is a 1 minus. So what's my least common multiple? 2 and 1 is 2. So how many magnesiums do I need to produce 2 electrons? I need 1. Good. How many bromines do I need to consume 2 electrons? 2. So what do I have? MgBr2. And notice we don't write down a 1 subscript. If it's just written as Mg, that means there is 1. All right, so that is my formula. How do I name it? Metal first, magnesium, and then my stem, brome, and then my ide, magnesium bromide, my metal, and then my anion name. That's how simple. Magnesium bromide. Wunderbar. Next, you guys try this one. Pause me and bring me back when you're ready. Okay, what do I have here? I have nitride and I have potassium. So that means I have K and N. I look at my periodic table. Where is K? Here's my K. It is a what? 1 plus. Where's N? No, 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 no. N is what? 1, 2, 3. It's a 3 minus. Good. So I have a 3 minus and a 1 plus. So this is a plus. This is a 3 minus. What's my least common multiple? 1 and 3. My least common multiple is 3. How many potassiums does it take for me to get to 3? 3. How many? So that means I need 3 potassiums to give up 1 electron so that I get 3 electrons here. How many nitrogens does it take to consume 3 electrons? 1, right? Good. So I have K3N. Excellent. Now, how do I name this? Potassium. Potassium. What? Nitride. There we go. Okay, if you got that right, go to the refrigerator and get some ice cream. Yay. All right. Whoops. Whoops. Yeah, okay, here we go. Now let's try one more. Give this a shot. All right, do you have an answer? We have magnesium and we have nitrogen. Magnesium is a 2 plus. My nitrogen is a 3 minus. What's my least common multiple? 6. How many magnesiums does it take me to get to 6? So this is 6 electrons, right? How many magnesiums does it take to create 6 electrons? Well, I need 3 magnesiums giving up 2 electrons each to get 6 electrons. How many nitrogens does it require to consume 6 electrons? Well, each nitrogen is going to take 3, so I need 2 nitrogens. So I have Mg3N2, and what's my name? Magnesium nitride. Excellent. Hee hee. This is a piece of cake, isn't it? Good. Moving on. Let's take a look at the ionic compounds formed between bromine and iron. Oh, this should be a piece of cake, yes? I use that term too much. We need to start using something else. Good. Iron, we go to the periodic table. Where's the periodic table? Here's iron. Uh-oh. We have 1, 2, 3. What about all these guys in the middle, transition metals? What do they make? Do they make a +1, +2, +3, +4? Egads. I'm not sure. Well, the answer is they make a whole bunch. Some of them are +1, some are +2, some are +3, some are +4. Oh my, some might even be +5. So what do? Well, we go back and take notes. That's what we do. Here we go. I got some bad news for us. We have to... Oh, no, we know that already. We learned that last time, right? We said, hey, look it. Iron is a +2 or a +3, right? Yeah, we know that already. Good. Well, what is it? We know that iron and my D blocks form multiple cations, so it could be iron +2 or it could be iron +3. And if they don't tell me, we really need to form both of these. Bromine is going to be a -1, a 1 minus, sorry. Bromine's 1 minus. What's my least common multiple in the first case? 2. How many irons do I have here? I have 1 iron. How many bromines do I have? 2. So this would be FeBr2. In this case, my least common multiple is 3. How many irons does it take to get to 3? 1. How many bromines? 3. So I'd have FeBr3. Okay, and so what's my name? Iron bromine, not bromine, iron bromide, and iron bromide. But how do I tell the difference between the two of these? Well, same thing we did before. We're going to take our charge on our cation and put it in parentheses. So this becomes iron 2 bromide, and this becomes iron 3 bromide. Okay, so let's just add that to our naming here. In naming, for metals with multiple cations, write the charge after metal as a Roman numeral in parentheses. Okay, that's just following the rules we used before in naming cations, right? Good. Here you go then. The ionic compounds formed between nitride and lead cations. Give that a shot. Give me a pause and bring me back when you're done. Well, if you recall from our notes, the last lecture, yikes, we said that lead forms what? A +2 and a +4. So lead is a +2 +4. So I can have lead 2, or I can have lead 4. And nitrogen. Nitrogen, we should know now, is a -3, a -3. Okay, what's my least common multiple between 2 and 3? 6. So I have how many leads does it take me to get to 6? 3. How many nitrogens does it take to get to 6? 2. So I'm going to have PB3 in 2. Well, what's my least common multiple with 4 and 3? Well, what? Is it 6? No, 4 doesn't go evenly into 6. 9, 8, how about 12? 12. So how many leads are necessary to create 12 electrons? How many lead 4s? Well, I need 3 of those. How many nitrogens do I need to become nitrides to use up 12 electrons? 4. So I would have PB3 in 4. Good. Now what are my names? This would be lead what? 1, 2, 3. Lead 3. No, it's not. Not this number. What goes in parentheses? Not the subscript, but what? The charge, right? Lead 2 nitride. And what's this? Is this lead 3? No, it's not lead 3. It is lead 4. Lead 4 nitride. Got it? Cool. Cool. Excellent. Moving on. All right, you name, let's see, how do we name this? Well, we've got CrCl2, and we go to our periodic table, and let's find Cr, and where's Cr? Ooh, Cr is a transition metal. That means it could have multiple cations. How do I figure out then what its charge is? Well, let's look at my chlorine. My chlorine is what? A -1. Got it. Okay, so what do we do know? We have Cr, and I don't know what its charge, and I have Cl, and it's a -1, right? And how many of these Cl's do I have? Well, I have 2 Cl's. If I have 2 Cl's, how many electrons are needed to have 2 Cl minuses? Well, I need 2 electrons. Well, where do those electrons come from? Both those electrons have to come from where? My chromium. So what if 2 electrons are lost from my chromium, then what is the charge of my chromium? It is what? 2+. You guys follow how I did that? Each chlorine gives up 1 electron. I have 2 chlorines, so that means 2 electrons. Excuse me, each chlorine uses 1 electron, and I have 2 chlorines, so that means 2 electrons have to be available. And where do those electrons come from? They come from my 1 chromium. And if 1 chromium loses 2 electrons, then it gains a charge of +2. So that means I have what? Chromium 2 chloride. Got that? Not so bad. All right, you guys give this one a shot. Well, we have W. W is what? W is tungsten and oxygen. And when I look at my periodic table, where is W? W is down here. It's a D block. It could have multiple cations. My oxygen is a -2, 2 minus. So I know I have a 2 minus here. And how many of them do I have? I have 2 of those. So that means what? 4 electrons have to be available to convert 2 oxygens to 2 oxides, right? So where do those 4 electrons come from? They come from my tungsten, which means my tungsten must have been, after it loses the 4 electrons, it becomes a +4. Got it? So then, that's the charge on my tungsten. So I have tungsten what? Tungsten 4 and what? Oxide, right? Do I have to say what the charge on my anion is? No, I never do. Tungsten 4 oxide. Got it? Great. Last one, and then we'll call it a day. Here we go. What do you say? Well, we notice that cadmium is a D block metal, so we have cadmium, and I have chlorine, and I have 2 chlorines. That means I'm going to have 2 electrons that the chlorines take up. And where do those electrons come from? They come from cadmium. So cadmium is going to be a 2+. So it's cadmium 2 chloride. Right? Wrong. Yeah. Wrong? What do you mean, Mr. Smith? Clearly, it's cadmium 2. That is true, ladies and gentlemen. But do you recall the other day we said, what about cadmium? Cadmium, zinc, and silver always form only one cation, meaning what? They do not need a charge in parentheses. So I do not write cadmium 2. I simply write what? Don't write that. I simply write cadmium chloride. Just the way I would write magnesium chloride. I wouldn't say magnesium 2 chloride or sodium 1 chloride. I just write cadmium chloride. And I just write silver chloride. Super. All right. Okay, let us call it a quits. Let us call it quits. Let us call it quits here. And next time, do I want to? How much time? Oh, yeah, we better quit. Okay, next time's going to be very... let's finish. This is a piece of cake. We only have 2 left. Let's get it done. Okay, the polyatomic ion compound. So we're talking about polyatomics, right, between sulfate and ammonium. All right, I know ammonium. I've memorized it. It's ammonium plus. My sulfate is SO4 2 minus. What's my least common multiple? 2. How many ammoniums am I going to need? 2. How many sulfates do I need? 1. What's going to go first? Well, my positive ion is going to come first. So it's going to be ammonium, and it's going to be sulfate. Now, how do I write down 2? Well, if I write down a 2 here, what does that mean? That looks kind of confusing. Am I talking about, is it 42 hydrogens? Or what? So I put this in parentheses. So that says ammonium 2 sulfate. Got it? So if I have more than one polyatomic, I put the polyatomic in parentheses and then put the subscript outside of the parentheses. And naming it, we just name it with all the other rules. Ammonium, and what's this? Not sulfide. That is, you've memorized it well. It's ammonium sulfate. There we go. You guys give this one a try, and then we're done. All right. Cobalt 2. So I have cobalt 2 and phosphate PO4 3 minus. What's my least common multiple? Looks like 6. How many cobalts do I need to get to 6? How about 3? How many phosphates do I need to reach 6? 2. So that means I need CO3, phosphate, PO4. I need 2 of those, so I'm going to put that in parentheses. Boink. Got it. And what do we call this? Cobalt. What? Cobalt, not the subscript, but the charge. Cobalt 2 phosphate. Woohoo! Egads, yay! There we go, folks. We are done. I put my little tie on and put a little hair there, not much, and some eyebrows. Great day. So, see you next time.